All right, review number 2. All right, this is the one I gave out today. So identify which triangle theorem. Again, I'll be mentioning them as I go. I'm not going to write down every single one as we go. I'm going to show you how to solve each of these problems. So the first 3 problems on here all go back to the last section. You will see a couple of questions from the last test. So on here, for example, we know that this is an isosceles triangle because those 2 base angles are congruent. So the converse of isosceles triangle theorem says that these 2 sides must be congruent. So we can set those 2 sides equal. So 4x minus 11 equals 2x plus 3. Subtract 2x on both sides, leaves us with 2x there. Add 11 to both sides, that gives us 14. Divide by 2, and x is 7. They don't care what x is, they want to know what the base is. So we got to plug that back into this one down here. So 6 times 7 minus 5, that's 42 minus 5, which is 37. So that's the first one, that's the base. So the base here is 37. The other part that they want us to find is the angle at the top. Well, 180 minus 65 minus 65 leaves us with, let's see, 65 and 65. That's going to give us 130. So that subtracted from 180 leaves us with 50. So 50 degrees for that top angle. Those are our 2 answers. Yep. Now, on number 2, we have what are the value of u and v? Well, we know that this angle here is also 63 because those 2 are congruent. You can use a number of different properties on this one. We know all 3 of those have to add up to 180. So if I subtract those from 180, 180 minus those add up to 103, leaves us with 77 for u. Now, for the other one, I'd actually use exterior angle theorem. So subtract off the 63. So 108 minus 63 leaves us with, let's see, that'd be 45 for this top angle. Again, exterior angle theorem says that the 2 remote interiors have to add up to the exterior angle. On this one, now we're using a property of an equilateral triangle. All the angles in an equilateral triangle have to be equal. In fact, they have to be 60 degrees. So, well, I should say any equilateral triangle has to be equal angular. So an equal angular triangle has to be 60 degrees. So that 10y has to equal 60 degrees. So divide by 10, and y is 6. Number 4, name the following construction. So on this one, that's an angle bisector. Angle bisector. I'm just going to abbreviate. This one's a perpendicular bisector. This one is a median because it's going from midpoint to opposite vertex. This one's an altitude. It's perpendicular and goes to the vertex. Then we have what point of concurrency is equidistant to the vertices? Well, that would be the circumcenter. What point of concurrency is known as the center of gravity? That is the centroid. What is the point of concurrency of the altitudes? That's the orthocenter. What point of concurrency is equidistant to the sides? That's the incenter. Again, you should know all this vocabulary, taking a quiz on it twice, although the results of those quizzes still weren't that great. They were an improvement from the first time around, but again, we still need to make sure we're studying that vocab. All right, on number 8. This is based on the idea of perpendicular bisector. Here they tell us we have a perpendicular bisector. So that means that this point has to be equidistant to both the endpoints. So we set them equal and solve. 33x plus 2 equals 35x minus 4. Subtract off the 33, leaves us a 2x. Add the 4, gives us 2. Divide by 2, and x is 3. They just wanted the value of x. That's all we got to do. On the next one, I forgot to put directions on this one, but I do want you to just solve for the variables. They didn't tell us that we have a perpendicular bisector this time, but since they labeled these as congruent, we know the opposite sides have to be congruent because of converse of isosceles triangle theorem. Once you know that those are congruent, well then this point is equal distance to both endpoints and it's perpendicular to this side, so this must be a perpendicular bisector, meaning those 2 must be congruent as well. So we can set those 2 equal in one equation. 3x plus 51 equals 11x minus 13. The other equation for y would be 2y plus 20 equals 5y minus 4. So if we solve this one first, subtract 3x, you get 8x. Add 13, you get 64. Divide by 8, and x is 8. On this one, subtract 2, you get 3y. Add 4, you get 24. Divide by 3, and magically, y is also 8. That's not always going to happen. Okay, number 9. Compare and contrast the radius of a circle inscribed versus circumscribed in or around a triangle. So, inscribed, the radius is going to be the distance from the incenter to a side. The circumscribed circle, the radius will be the distance from the circumcenter to the vertex. So, the circumscribed circle is always going to be larger. So, radius of circumscribed circle always larger distance from circumcenter to vertex. Whereas again, the incenter to side is radius of inscribed circle. So again, there's lots of different things you could say, but that's some of the main differences. All right, on number 10, they give us mx is equal to 18. So mx, that's the entire length. Well, the little piece here is going to be a third of the overall. This is going to be 2/3, because again, our property here is that the distance from vertex to midpoint along a centroid, let me try that again. Distance along a median from our vertex to our midpoint is 2/3 to get to our centroid. So I had you guys originally go something like this. If that's x, this is 2x. So that this is a third of the overall leg. This is 2/3 of the overall leg. So again, keep that in mind as we're doing this. On this one, if the whole thing is 18, and this is a third, it's 6. This is double that, it's 12. Together, it's 18. KW, it says is 10. So I can label this as 10. Which means if this is the longer one, this is only half of that, that's 5. And the whole thing would be 15. For ZW, it says is 4, so this would be double that. This would be 8, so the whole thing is 12. The parts they want us to identify, they want us to identify MW. So MW was 12. WY is 5. And ZL, add those together, and that's 12. And that's it. All right, 11 and 12 take a little bit more time, so I'm going to skip those and come back to them. The ones on the test for those two are a little bit easier, but I do want to come back to those two. Number 13, went over this in every class, but I'm going to say it again. These are all the same point in an equilateral triangle. So that's the only time they're all in the exact same place. So incenter, circumcenter, centroid, and orthocenter for an equilateral triangle are the same point. Same point. Again, the reason for this goes back to our properties from last chapter. If you were to draw an isosceles triangle and draw in an angle bisector, it is also the perpendicular bisector of the opposite side. Now, that segment we just drew in fits the definition of an angle bisector, of a perpendicular bisector. It also fits the definition of median, since it goes from midpoint to vertex, and it fits the definition of altitude, since it goes from vertex perpendicular to the opposite side. So since this line can be called any of those things, and it's in the exact same place, that's why this works. Because now when we talk about equilateral, an equilateral triangle is isosceles, but it doesn't matter which one we call the vertex angle. So if we drew these parts in for the other angles, now this isn't the best drawing, but if we drew them in for all of them, they intersect in the same place. Again, each of these lines, same thing, and they all have the same point. So that point is the incenter, the circumcenter, the centroid, and the orthocenter all at the same time. And that's only for an equilateral triangle. Okay, on the back. Which figure correctly shows the following parts? So the medians, if we look at these, the one that shows the medians is going to be figure A. Figure A shows the medians. Then we have the altitudes. So from vertex perpendicular to opposite sides, that's figure C. Angle bisectors, that'd be figure B. Perpendicular bisectors, that'd be figure D. What point represents the following points of concurrency? So again, that's looking back at the ones up here. So the incenter is where all the angle bisectors meet, so that'd be L. The circumcenter is where all the perpendicular bisectors meet, so that'd be H. The centroid is where all the medians meet, so that'd be Z. And the orthocenter is where all the altitudes meet, which is Q. So those are the correct values for each of those. Let me screw this up so we can do these last few. All right, on this figure, so we have our diagram. It's telling us that it shows the medians and the centroids. So Z is our centroid. Find the missing measures. So CZ, it says, is 14, therefore this is 7. So let's see, is ZT there? I don't see it. But what about CT? Yep, add them together, you get 21. CZ was 14. And I think that's it for that line. So the next line. All right, we got RZ. RZ is 6. So that means that this piece is 12 and the whole thing is 18. So, see, is RZ down there? Nope. Is ZA down there? Yep, that's 12. How about RA? Yep, that's 18. Then we have BS. The whole thing is 36. So if we take a third, that's going to be the smaller piece. So this is 12. And this is 24. So ZS, not down there. What about BZ? BZ is, that's 24. Now, they also gave us a few other parts here. So let's see, we have CR is 20. Well, again, these are the medians go to the midpoint, so these are midpoints here, so they split it and bisect the sides. So if CR is 20, that means that RB is also 20. Then they told us that CS, or we're looking for CS, they gave us CA. CA is 28. So again, this is a midpoint, so this is being bisected, so this is 14 for CS. And then for AT, well, they told us that this piece is 3x. They told us that this is x plus 42. So those two must be equal. So we actually have to solve on this one. The x equals x plus 42. Subtract x, that's 2x equals 42. Divide by 2, x equals 21. We want AT, so plug it back in. 21 plus 42 is 63. All right, go up to the top. On this one, the thing that we have to know here is that they tell us this is the circumcenter. The circumcenter is equal distance to the vertices. So this line, CH, HA, and BH, are there for the main purpose of knowing that those have to be equal distance to the vertices. So we were told CH's length is 10. That means all of these are 10. So HA is 10. For BE, they told us BE is 8, so EC is also 8, because that's a perpendicular bisector. It's split that one in the middle. Then we know that BA, this whole side, is 18. Well, they want DA, so half of that is 9. And the last one is a little bit harder. We have to use this triangle right here. That's a right triangle. They're looking for this side. So let's call it B in the meantime and use Pythagorean theorem to find it, because to find the missing side of a right triangle, use Pythagorean theorem. 10 squared is equal to 8 squared plus B squared. So that's 100. That's 64. Subtract 64, you're left with 36. Square root it, and you have 6 is equal to B. On 17, we have Emily's dad can't decide where to build McDonald's. There are 3 main roads. Show why the good choice would be in-center and circumcenter. Well, the in-center is equidistant to the sides or the roads. So in-center equidistant to sides, which are the roads. Circumcenter equidistant to the points or the locations. So that's why those two make good options. You will see questions like that on the test. All right, on number 18. Can the following be lengths of the sides of a triangle? So we did some of these on the other review, but again, in order to be a triangle, the two small sides are going to have to be greater than a third. So 5 plus 4 is 9, so that is greater than 8. 6 plus 7 is 13, that is not greater than 14. 9 plus 3 is 12, which is greater than 10. 5 plus 5 is 10, it's not greater than 10, so that doesn't work. On 19, what is the range of possible values for the third side? So again, we have to find the sum and difference on each one of these. So let me just set it up so that we're finding the third side here. Subtract them, you get 5. Add them, you get 15. So between 5 and 15 centimeters. On this one, subtract them, you get 5. Add them, you get 9. So between 5 and 9 inches. On this one, subtract them, you get 2. Add them, you get 26. And that's in meters. And the last one is in feet. Subtract them, you get 4. So 4 feet to 12 feet when you add them. That's it. On 20, what is the error here? Well, this is not a perpendicular bisector. Perpendicular bisector should have been somewhere over here. So when we did these arcs, the setting must have changed. So this one is in the wrong place. So one of the lines is not a perpendicular bisector. All right, and that's it for that review. I did skip 2 questions, so I want to go back to those 2 real fast. I want to say, though, that the answer for these, it's a little bit hard, but on the test I made it a lot easier. So I'm going to show 2 of my answers. Hold on. I'm going to show 2 of my answers that I got in class for number 11. There they are. 2 different ways of doing that same problem, but they both got 3, -1. Now, are doing these by finding midpoint and then by partitioning a segment. However, I'm telling you right now, on the test, it is much easier just to look at the graph because I'm going to give you a diagram. And as long as you know that the centroid is where all the medians meet, and you draw on your medians on the graph and find out what point they intersect at, you'll find your centroid. Or if you know that, if you can draw one of your medians and know that the centroid is 2/3 the distance from the vertex to the opposite midpoint, you'll find the centroid. Again, I would not spend time doing any of this work on the test because you have a diagram. Use the diagram. All right. So again, I'm not going to do 11 and 12 because again, it is different on the test. This work is much harder. It's much more time consuming. This will probably take you more than 5 minutes. Not time you should be wasting on it. So don't do that work. Know your properties and use the graph. All right, that's it for the review.